Good morning to all of you. In previous session, we have discussed three properties of Z transform, that is linearity, time shifting, and scaling in the Z domain. In today's session, we will be discussing time reversal property, and we will try to identify the Z transform by using time reversal property. So, we will be discussing time reversal property of Z transform. So if again x of n as a discrete time signal having Z transform capital X of Z and with ROC R1 less than mod Z less than R2, then the time reverse signal, that is X of minus n, as the Z transform capital X of Z inverse. Okay. So here you have reversed the time. In place of n there is minus n, so in Z domain its Z transform will be modified as the Z will be replaced with Z inverse. Okay. And the ROC will be modified as it will be 1 upon R2 less than mod Z less than 1 upon R1. Okay. So let's try to prove this property. So proof, again we know that the Z transform of X of n, that is capital X of Z, is summation n is equals to minus infinity to infinity X of n into Z to the power minus n. Okay, so that is the formula of Z transform. So here we are interested in identifying the Z transform of X of minus n. Okay. So in formula, in place of X of n, we will substitute X of minus n. So it will be summation n is equals to minus infinity to infinity X of minus n into Z to the power minus n. Right. So here again we will try to replace this small n with minus l, just for example. So this can be rewritten as summation minus l is equals to minus infinity to infinity X of l into Z to the power, in place of minus n there will be l. Okay, so I'll rewrite this one. So we are interested in identifying the transform of X of minus n. So here we will get this minus l is equals to minus infinity to infinity X of l into Z to the power l. Okay. So again this minus sign I can send inside these summation values, so it will be again simply l is equals to minus infinity to infinity, right? Because the negative sign will get multiplied with each value, right? And this X of minus l will keep as it is, and this Z to the power l can be written as Z to the power minus 1 raised to the power minus l. Okay, so this minus minus will be plus, so it will be simply Z to the power l only, right? So if you compare this one with the Z transform formula, what is the formula for Z transform? So X of Z is equals to summation n is equals to minus infinity to infinity X of n into Z to the power minus n. Okay, so if you compare it with the Z transform formula, so in place of n there is variable l. Okay, the rest of the things are same, that is values are not varying from minus infinity to infinity. It is X of l, so it is X of n. In place of n simply l is there, and Z to the power minus n, so in place of Z there is only z inverse. Okay, so the remaining things are same, right? So only in place of z there is z inverse, right? So that means in place of z we will keep here z inverse, so it is nothing but x of z inverse. Okay, so the z transform of x of minus n is nothing but x of z inverse. Okay, so simply you have to replace z with z inverse. Okay. So initially the ROC of x of z was r1 less than z mod z less than r2. So as here it is simply in place of z there is z inverse. So the ROC of this x of z inverse will be written as r1 less than mod z inverse less than r2. So if I send this z inverse on right hand side and send this r1 z inverse on left hand side and r1 on right hand side, so it will be 1 upon z inverse, it will be 1 upon r1. Similarly here it will be 1 upon z inverse, here it will be 1 upon r2. So this will be uh, if I'm taking 1 upon z inverse in numerator, so z inverse is taken in numerator, so it will be z, so z less than 1 upon r1 will be there, and here it will be 1 upon r2 less than z. Okay, that means z is greater than 1 upon r2 but it is less than 1 upon r1, right? So this can be simply written as, this ROC can be simply written as 1 upon r2 less than mod z less than 1 upon r1, right? So if I am sending these values on left and right sides, right? So I will get this relationship. So this is nothing but the time reversal property. If you are reversing the time, okay, or you can say that you are negating the time, so in z domain its z transform will be modified likewise, where z is replaced with the z inverse. We have proved this property here, okay, and we have also obtained its ROC. We will try to identify the z transform by using the time reversal property. So here the given signal x of n is equals to u of n, and we have to determine the z transform. So initially we will try to identify the z transform of u of n. Okay. From u of n we can identify the z transform of u of minus n by using this time reversal property, right? So we'll initially try to identify the z transform of u of n. Okay. So the z transform of u of n can be simply represented as summation n is equals to minus infinity to infinity x of n into z to the power minus n. So in place of x of n there is u of n into z to the power minus n, right? So again here I can take this summation limits instead of from minus infinity to infinity, 0 to infinity I can take, because for negative values of n this u of n is 0. Okay. And so I can simply write it down as n is equals to 0 to infinity, and for these values from n greater than or equals to 0 the u of n is 1, so it will be simply z to the power minus n. So again I can rewrite this equation as summation n is equals to 0 to infinity z inverse raised to the power n. Okay. So again, as per the infinite geometric series, that is for summation n is equals to 0 to infinity a to the power n is equals to 1 upon 1 minus a, provided mod a less than 1, right? So here I can write it down as 1 upon 1 minus z inverse, right? that mod z inverse should be less than 1. So its ROC will be, I will be sending this z inverse on the right hand side, 1 upon z inverse, right? So 1 less than z will be there, so that means mod z is greater than 1. So this is the z transform of what u of n. So now what we have now, we have determined the z transform of u of n, and its z transform is 1 upon 1 minus z inverse with condition, that is with ROC mod z greater than 1. Okay, so mod z greater than 1. So as per time reversal property of z transform. So what is time reversal property? I'll rewrite here. So if x of n has z transform x of z with ROC R1 less than mod z less than R2, then x of minus n has the z transform x of z inverse. So this is nothing but your time reversal property, and the ROC is here 1 upon R2 less than mod z less than 1 upon R1. Okay. So as per this time reversal property of z transform, the z transform of u of minus n, okay, because we want to determine the z transform of u of minus n, will be simply x of z inverse. So wherever there is z, I will be replacing it with z inverse, right? So in this case, if I am replacing this 1 minus in place of z, I will be writing z inverse to the power minus 1 again, because minus 1 is there. So in place of z, I substitute z inverse, right? So this will be simply 1 upon 1 minus z. Okay, that will be the z transform of u of minus n. The z transform of u of minus n will be 1 upon 1 minus z, and ROC will be as per this condition. So this initially said this R1 was less than z, that means z was greater than R1. Okay. But here this R1 has been now sent to right hand side. Mod z is now less than 1 upon R1. So if I am sending it 1 upon R1, so it will be simply mod z less than 1. Okay. Mod z less than 1 will be the ROC for this z transform of u of minus n. Okay. This is the what required z transform as per time reversal property, and its ROC will be mod z less than 1 second. Okay. So here we are seeing time reversal property. We also obtain its proof. We also determined its ROC, and by using time reversal property, we identified the z transform of u of minus n. Okay. So in next session, we'll be discussing next property, that is differentiation in the z domain. So thank you for joining this session.